go ahead and get this paper out. We're going to go over this. Give you a good idea of how to do these kind of questions. If a system at equilibrium is subjected to a stress, stress means that you're going to make some kind of change. The equilibrium is displaced in the direction that relieves the stress. In other words, it wants to counteract or neutralize whatever action you have taken. A stress is defined as any change which could affect the rate of either or both the forward and reverse reactions. When, because of an applied stress, the forward reaction is faster than the reverse reaction, the system is said to shift to the right. As a result, the products will increase and the reactants will decrease. When, because of an applied stress, the reverse reaction is faster than the forward reaction, the system is said to shift to the left. As a result, the products will decrease and the reactants will increase. In simpler terms, if anything is added to a system at equilibrium, the system will try to consume whatever was increased. If anything is removed from a system at equilibrium, the system will try to replace whatever was removed. So the reaction is favored away from what is added and toward what is removed. So these are the basic ideas behind the Chateliers principle. What we're going to do now is go over a series of situations, and you can see how to answer the questions, and then that'll help you with the other paper that was handed out. In the following reaction, will the hydrogen concentration, the H2 concentration, increase or decrease when the equilibrium is reestablished after these stresses are applied? So in the italics part, we're going to change something. We're going to create a stress, and then basically we can just say increase or decrease, and all we're paying attention to is the amount of hydrogen concentration. So NH3 is added. Okay, NH3 is over here on the right side. Remember, when we add, we go away from that. So this is basically going to be a shift left. And if it shifts left, okay, that's this way. Shift left then means the H2 will increase. Okay, so a shift left, whatever direction we call, that's the side those things become higher concentrations. Okay, N2 is removed. All right, N2 is on this side. Removing, we want to go toward whatever is removed. This will also be a shift left, which means again we would increase the amount of H2. In other words, we had a certain amount, then we took out some of the nitrogen, and so what it did is it took the ammonia and turned it back into nitrogen and hydrogen to try to compensate for the fact that we removed some of the nitrogen. All right, now our change is pressure is increased. Okay, remember from the notes, the rule is if I increase the pressure, it wants to go to the side with more moles. Is that right? Or go to the side with less moles. Do you remember? Okay, increasing the pressure is the same thing as kind of like decreasing the volume. They go together. So if I have less volume and it wants to compensate for that, in other words, have just as much room, if you will, or just as many collisions as it had before, it needs to decrease the number of moles that are involved. Well, on this side, I have 1 mole, even though it's not listed, there's 1, and 3 moles of the hydrogen. So there's 4 moles of molecules on this side. There are only 2 moles on that side. So an increase in the pressure goes to the side with fewer moles. So this will shift right. Shifting right means make more of NH3, but if you're making more of this side, you are making less of that side. So it will decrease the amount of H2. So again, increasing the pressure or reducing the volume, they go the same way, or they go in opposite directions. That will go to the side with fewer moles. Temperature is increased. Okay? If the temperature is increased, we want to counteract that effective increase in temperature. Well, right there, we're basically adding energy. Okay, this is on the product side. This is exothermic. We are adding energy as a result of the reaction. We want to go away from that side. We want to go away from the KJ side when the temperature is increased. So this will be a shift left, and therefore we will increase the amount of hydrogen. So to just recap real quickly, we added a product, therefore it shifted left, which means increase the hydrogen. We removed a reactant. It shifts towards things we remove. So again, it was a shift left. We ended up increasing the amount of hydrogen. Increase pressure. Go to the side with fewer moles. 1 and 3 make 4 moles on that side, only 2 moles on this side. So a shift right, which means increase this, but decrease these guys. And then finally, temperature is increased. Go away from the KJ side. Go away from the energy that has been produced here, which means shift left, and we have an increase. All right, in number 2 here, we're going to note this reaction. NO plus H2 goes to N2O plus H2O plus, again, we are producing some energy, so another exothermic reaction. In which direction, left or right, will the equilibrium shift if the following changes are made? So all we have to do in this case is we can just write R's or L's for whether it would be a shift right or a shift left. So let's start off with, we add NO. Okay, again, the rule is we always go away from what we add. NO is on the left, so this will be a shift right, away from the side we added. H2 is removed. H2 is on the left. We go toward the sides we remove, so we will go towards the left. Okay, this is really the hard part of the whole idea. It's always doing the opposite, okay, of whatever has been done. N2 is added. Okay, well the N2O, that's over here on the right side. Therefore, we want to go away from what's ever added. Shift left. The system is cooled. That'd be the same as saying the temperature is decreased. Now, up above, when we said the temperature is increased, we shifted away from the KJ side. If the system is cooled, we would shift toward the KJ side, and therefore this one would shift right. Okay, pressure is increased. Again, we want to go to the side with fewer moles. We have 2 moles here, 1 mole there. That's 3 on the left, 1 and 1, only 2 on the right. So we would shift right in this case. Again, toward fewer moles. And then finally, H2 is removed. H2 is on the left. We go toward whatever we removed. So that one would go to the left. All right. We're going to do a similar thing to what we just did with lefts and rights. First off, however, is heat absorbed or released by the forward reaction? Okay, first off, we got to go find where the heat is. Heat is here. If that had been kJ, that still represents heat, energy. So it's on the left side. If it's on the left side, we say it's absorbed, which is endothermic. The previous reaction, it was on the right side, which would mean it's released, and we would say it's exothermic. All right, just as before. In which direction will the equilibrium shift if these changes are made? Okay, we're going to add CO. CO is over here on the right. We added. Go away from whatever we add. Shift left.
Shift happens.
CO2 is added. CO2 is on the left. Go away from what we add. Shift right. H2 is removed. H2 is on the left. Shift toward what we remove. Shift left. Catalyst is added. Anybody remember from our notes what happens? Shift with. We have no shift. Okay? It just goes faster. All right, but both directions go faster, so it gets to equilibrium quicker, but it doesn't change the concentration amounts. Okay, temperature is increased. Go away from the heat side. Go away from the KJ side. That's on the left. So we go right. System is cooled. Okay, if it's cooled, that's the opposite of the temperature is increased. So we go the opposite direction. And pressure is increased. Okay, go to the side with fewer moles if the pressure is increased. 1 and 1, that's 2. 1 and 1, that's also 2. If the moles are equal on both sides, there's nowhere to go to the smaller side. We have a no shift. Okay? So there's actually 2 different ways we can have no shift. Adding a catalyst or the number of moles on both sides is the same. All right. I want you to do 2 things for number 4. I'm going to give you a couple minutes and then we'll go through them real quick. First off, over here on the side, I want you to put L, R, or no for what kind of shift. So right here to the left of our changes, and then in the blank spot, say what happens to the H2O. Does it increase, decrease, or no change? Okay, so again, L, R, or no to the left of these. and then increase, decrease, or no change. Yes?
In this case, the heat is like the kJ, right?
Yes. Heat, kJ, think of them, energy, all the same thing. All those different terms. Okay, the simplest way to look at it is always go away from what gets increased, go toward whatever gets decreased. So, temperature is increased, go away from the heat. Heat's over here on the right, shift left. Catalyst, no shift. Pressure is decreased. We go towards the decreased things. In this case, we want more moles instead of fewer moles. So 2 and 1, that's 3. 1 and 1, that's 2. So we are going to shift left. NO is added. Go away from whatever's added. Here's NO on the left. Shift right. N2O is removed. Go towards whatever's removed. N2O here on the right. So we shift right. Now that I know that, what happens to the H2O? Okay, if I shift away from the H2O, it goes down. If I shift towards the H2O, it goes up. So left, H2O is on the right, so this one will decrease. Catalyst, no change. Again, shift left, decreased. The shift rights will increase the amount of H2O. And our last example. How would an increase in pressure? So this is the one change to all three different situations. We're going to increase the pressure, affect the amount of H2. And again, I would always start with, okay, increase pressure, go to the side with fewer moles, because the increase, go away from the side with more moles. 3 here, 2 there, so that's going to be shift left, or excuse me, yeah, we're increasing the pressure, so we want to go away from that, so it's a shift right. Go to the side with fewer moles. Here we have 4 and 1, that's 5. Here is 3 and 4, that's 7. Go to the side with fewer moles, because we're increasing the pressure. And here, 2 and 2, so no shift. Yes?
My question was, wait, hold on, I forgot. How do we know if we go away from it or towards?
Anything that's being,
more moles or less moles?
okay, increased pressure, we want to go to less moles. Yeah, and think of it this way. You know, pressure is about collisions, okay? The more collisions, the higher the pressure. Okay? Well, if we have increased the pressure, we want to offset that pressure. We want fewer collisions, so we go to the side with fewer moles. All right, so now that we know that, we're looking at what happens to the H2. Okay, H2 is on the left. We shifted right, so decrease in the H2. H2 is on the left. We shifted left, so increase in the H2. No change. No change in the concentration. All right. Any questions? Okay.